All right, so this week we're going to be focusing on, as I said, solving systems of equations, which generally means that you're solving equations for more than one variable. We will do some equations where you're solving for 2. We're going to do some other equations where you're solving for 3. But in general, there's no limit. You could solve for an equation with 10 variables. Some of the approaches that I'm going to show you, like substitution and elimination, they work fine for 2 or 3 variables. But if you start getting up to more variables than 3, like 4, 5, 6 variables, we're going to want to think about how to solve it a different way that would be a little bit more organized. So then I'm going to show you how you can solve in a different way tomorrow. Okay? And the way that I'm going to show you tomorrow works really well when you have a lot of variables. But substitution and elimination will be okay for today. All right, so let's just jump into a problem. We're not going to solve it yet. I just want to set it up. So just by reading what it's asking you to find, how many variables do you think this first problem is going to have? 2. Yeah, what are they going to be?
X and Y.
You could let them be X and Y, and that's going to represent the length and the width. I would say if we're going to do something with graphing, we probably want to use X's and Y's. If they're just asking us to set up a system, you could use L and W for length and width. So they're telling us 2 things. The perimeter of the rectangle that I'm thinking of is 100, and the area is 300. So it says to find. We're not going to find it yet. We're just going to set it up. I think we're going to find it in the next problem. All right. So there's 2 formulas, perimeter and area. First thing I need is, what's the formula for perimeter of a rectangle? Yep.
2 times the length times 2 times the width.
So 2 times the length plus 2 times the width. Okay. And what's the formula for area of a rectangle?
Length times width.
Length times width. Now, I don't know the length or the width, but I do know the P and the A. What do they tell me for the perimeter?
100.
Perimeter is 100. Okay. And what do they tell me for the area? 300. Yep. So that's a system of 2 equations. There are 2 equations, and there are 2 letters that you would be trying to solve for. And that's it. Any question on how to set the equations up? Okay, now I'm going to show you how you solve. So we're going to learn 2 methods for solving. Today. We're going to look at substitution and elimination. I'm going to start with substitution because that's going to apply to this problem, and then we'll do an elimination one after. So how do you use substitution? So step 1. Pick one of your equations and solve it for a variable. If we were doing the one that we just made up, which equation do you think is easier to get a letter by itself? Equation 1 or equation 2? Yeah, equation 2. It's going to be less steps. You can do one thing to get the L or the W by itself. So I would pick equation 2. Then, once you get a variable by itself, you're going to take that and you're going to plug it into the other equation. Once you do step 2, you should know one of your answers. Either the L or the W. Depends how you set it up. Now, once you know one of your answers, you can take that answer and you can plug it back in to get the other answer. doesn't matter which equation you use when you're getting your second answer. You can plug back in to either one. My advice would be to pick the one that is easier to work with. Okay, so we're going to solve this one now. We're going to use substitution. Yeah, that's the same problem. I'm just going to put it right below. Okay, so now solve. So we got 100 equals 2L plus 2W. 300 equals L times W. Okay, let's solve. So we said earlier we're going to use the second equation. And which letter do we want to get by itself in the second equation? The L or the W? W? I heard both W. No, it doesn't really matter. It's
L.
Okay. Okay, we're going to get L by itself. If you want to get L by itself, how would you move the W to the other side? You divide. So L would equal what divided by what? Yep. So 300 divided by W. So that's L. Right? So we did step one. Now plug that result into the other equation. Where is this going to get plugged in for what? For L. That's going to go right there. So you're going to have 100 equals 2. And now replace the L with 300 divided by W. And what do I still have to add on the end? Still have to put the 2 W. Okay. Now, looking at that, how many different letters are in that new equation? Just one. There's only one letter in it now, and now we can solve it. Okay, so we get 100. Let's see, 2 times 300 is going to give me 600 over W. Now, generally what we want to do is if you've got a fraction, we want to get rid of it. So the only fraction we have is because we have divided by W. What would undo dividing by W?
Multiply by W.
Yeah, multiplying by W. So you're going to do here, here, and there. Okay, you're going to do all three. Okay. What's 100 times W? 100 W. What's 600 times W divided by W? 600. That's gone. And what's 2W times W?
2W squared.
2W squared. Okay. And now, what kind of equation is that? It's a quadratic. And when we try to solve it, what do you always get a quadratic equal to?
Positive. No.
We have to get something on one side by itself.
Zero.
You always want to get 0 on one side. The easiest thing would be just to move the 100W over. So you got 2W squared. And then when we subtract the 100W, it's going to become negative 100W plus 600. So I also rewrote it in the normal order that you see a quadratic in. Okay. What's one way that you can solve a quadratic? You can try factoring. Now, we can actually make these numbers a little easier to work with before we try to factor it. Does anybody see what they're all divisible by?
2.
2. So, you don't have to. That's going to make it a little easier. All right. And now we're going to we could try to factor it. We'd have to find two numbers that multiply to give you 300 and subtract to give you 50. Can anyone think of two numbers that multiply to give you 300? Subtract to give you 50. I don't think so. Because you got 60 times 5. But that 60 minus 5 is 55. And you got 30 times 10. But if you subtract 30 and 10, you get 20. So it might not be factorable. What do we do if it's not factorable? Yeah.
Quadratic formula.
Yeah, let's try the quadratic formula. If it comes out nice, then it was factorable and we missed it. Okay, but let's try the quadratic formula. Okay, what's A going to be? 1. Just making sure. Make sure I divided everything by 2 correctly. W, 50, 300. Yep, looks okay. So A is 1. What about B? B is negative 50. And what about C? 300. Okay, so we got negative B plus or minus the square root of, we'll need to do that out, B squared. I know it's negative 50, but the negative doesn't matter there because it cancels out. So B squared minus 4 times what comes right after the 4?
A times 3.
1 times 300. All over
2A.
2A, and that's 2 times 1. All right, so we got 50 plus or minus, what's 50 squared?
2,500.
2,500 minus, what's 4 times 300?
Negative 4 times 300 is negative 1,200.
And 2,500 minus 1,200?
1,300.
1,300. The square root of 1,300, it's not a nice answer. So it was not factorable. Okay. And that, what did we just solve for? W. We just found W. Okay, let's round it off. So let's type it in. So 50. I'm going to just do the numerator first. And then divide by 2. So I'm going to get 2 possible answers for the width. That's the plus. 50 plus the square root of 1,300. If someone else can do 50 minus the square root of 1,300 and then divide by 2, I need that answer as well. So let's call the first answer 43.023. Alright, and how about when you do 50 minus the square root of 1,300 over 2?
Negative 6.972.
You got a negative?
It's just
Then,
6.9.
so it's 1,300 minus the 50.
Well, square root of 1,300.
Yeah, the square root of 1,300 and minusing 50 brings it to a negative.
The square root of 1,300 is smaller than 50. So 50 minus 36 roughly divided by 2. What did you get?
6.972.
6.972. Okay. Great. Is there anything else we need to find?
Yeah, we need to find length.
Yeah, we only found the width. We need to also find the length. So we're going to have an L1 and an L2. Okay, well, let's find it. So L1. Well, take your width and plug it back in. I would plug it in right here. If you use this, that will tell you how to find the length. It's just 300 divided by the width. All right, let's do the first one. 300 divided by 43. 343.023. I get 6.973. Does that look? Anybody notice anything about that number?
It's the width too. That was
Yeah, it's the other width. It's basically looking at a rectangle two different ways. So what do you think if I type in 300 divided by 6.972?
43.023.
Yeah, we're pretty close to it. 43.029. So that one came out.
Well, the width should be
You round that. No,
It was 2.7.
Yeah, 2.7, not 2.3.
Oh, it was 2.7, not
Yeah.
2.3. Okay.
So the 2.9 is pretty close.
So 43.029. Okay, so it's pretty close. They basically they are the same number. Okay. The difference is this top rectangle looks like this, and the bottom one looks something like that. It's the same rectangle, just rotated. So this is your, we'll call that's your first answer. Everything right there. And this is your second answer, right there. All right, any question on that? So in general, once you find one answer, you automatically know the other answer because it's just the width. It's just the width and the length switched. That's all. Right, so that's how you solve a system that's quadratic with two variables. Sometimes it might be factorable, and you don't have to use quadratic formula. Any questions on that? Okay, that's the one we just did. I had changed the letters to X and Y. Would that make a difference how you solve it?
No.
No, just different letters. Okay, let's try this one. So here's our two equations. So the first step is to pick an equation and get a letter by itself. Is there an equation here where it would be easier to get one of the letters by itself?
1.
Yeah, I would say equation 1 is definitely easier. Which letter, X or Y?
Y.
Yeah, Y is going to be the easiest one to get by itself. All right, so we're going to rewrite equation 1 with Y alone. How would you get Y alone in that equation?
Subtract 2x.
Yeah, just subtract the 2x. So Y would equal
5 minus 2x.
5 minus 2x. Okay, so there's your formula for Y. And where is this 5 minus 2x going to get plugged in?
Y.
into the y on the second column.
Yep, into Y in the second equation. Okay. And when you plug it in, you want to make sure that you use what symbols, because there's a property that's going to come up here. What symbols do we want to make sure we put?
Parentheses.
You want to make sure you always put parentheses, especially if there was something multiplied in front, because when you double the Y, you're doubling the whole thing. Okay, the 5 and the negative 2x. Yeah. Yeah. Okay, any question on how we got Y by itself or why we plugged it in right there? So now let's do it. 3x, and we're going to distribute the 2. 2 times 5 gives us 10, and 2 times negative 2x,
And 4x.
4x. Okay, combine like terms. What do you get on the left?
Negative x plus 10.
Negative x plus 10. Okay, next step.
Subtract 10.
Subtract your 10. Negative x equals
Negative 8.
-8. So what does positive x equal?
8.
8. So x equals 8. Anything else we got to do?
Plug the x back into the first equation.
Yeah, I would plug it. Go like this. I would plug it back in. Right there. So if you fill that back in, then you can get y. So y equals 5 minus, and what are we filling in for x? 8. So 2 times 8. That's 5 minus 16. Which gives me what for y? Negative. What is it? Negative 11. Okay. So there's a couple ways you can write your answer. You can write it x equals, y equals, or you could write it like this, as a coordinate. Now that's a special coordinate, because if you graph y1, or if you graph equation 1 and equation 2, what would happen at that point on the graph?
They would intersect.
That's where they would intersect. Yep. Okay, we're not really focusing on graphing to solve them, but if you did graph them, that's where they would cross. So that's a pretty standard substitution problem. That's not quadratic. That's just linear. Okay. Any questions on that? Okay. So that pretty much covers substitution. Elimination. So the idea with elimination is you're trying to make one letter disappear. Basically, you're trying to get variables to cancel out. And the way that you can do it is you add linear combinations, or you call that a multiple. You add multiples of one equation to another equation. So like if I had something like 2x plus 3y equals 12, and 6x minus 7y equals 3. There's a certain letter there that if I was going to solve that, I would focus on trying to get to cancel out. I would try to get the x's to cancel. And the idea is you find a number that you could multiply all three of those by, so that that becomes a negative 6. Did anybody see what you could multiply everything by? Yeah, you multiply everything by negative 3, and then you'd have a negative 6x and a positive 6x, and then the variables would cancel. Now you could make the y's cancel. It's not as easy. You'd have to multiply them both by something. I would multiply maybe the top by 7, and that would make it 21. And multiply the bottom by 3. That would make it negative 21. So you can make the y's cancel, but in this case it's a little more work. Right? And that's called a linear combination. Multiply an equation by a number.
Now, what about at the very end? Can you make those cancel out or no?
No, you want to make either the x or the y variable cancel, because you have to make it so there's only one letter left in the problem. So if you make the numbers on the right side cancel, you're still going to have 2 letters left. Yeah. So that's the goal. You have to get the coefficients of one of your variables to be opposites. 4, negative 4. 10, negative 10. Something like that. So in the problem I had up above, you have to multiply by a number to make the x's cancel. Sometimes you only have to do that in one equation. Sometimes you have to do it in both. Okay, so we'll try a few examples now of elimination. And that's really the last one we're going to learn today. We're going to do a couple elimination with 2 variables. Then we're going to get into an elimination with 3 variables. Okay, if you can do 2, you can do 3. 3 is just more steps, but they're not harder steps. It's more steps. Okay, let's try this one. So we got 2x plus 3y equals 5, and negative 3x plus 5y equals 21. Now, just to be clear, you can do substitution. If it doesn't say what method to use, and you think substitution is easier, you could do it. The problem with substitution is you don't have any variable that doesn't have a number in front of it. Substitution is really easy when there's no number in front of one. Okay, but we don't have that. All right. So first we have to decide what variable do we want to make cancel out, the x or the y.
The y.
The y? Okay, so we're going to make the y's opposites. Does anyone have an idea what number we're going to have in front of each of these y's? One of them will be the negative of this number, the other one will be the positive of it. Yeah? 15, that's the goal. We want to make the y's have a 15 and a negative 15. Yep.
Can I fill up my Y button?
Yeah. Okay. Start with the top one. What could you multiply the top equation by?
5.
Yep. You got a couple choices. You could have done 5 or negative 5. Now that we did 5, you don't have any choice for the bottom. So this is going to be multiplied by 5. And what's the bottom going to have to be multiplied by?
Negative 3.
Yeah. That's going to be negative 3. All right, let's do it out. Can someone tell me what do you get when you multiply the top by 5? Whole new equation.
10x plus 15y equals 25.
10x plus 15y equals 25. Yep, looks good. And what about when you multiply the bottom by negative 3?
Just the entire thing by negative
Alex,
3.
can you shut that one?
Oh, sorry.
Oh, you're good. Sorry, go ahead.
The entire thing by negative 3?
Yeah.
That would be positive 9x minus negative 15y
Say that again.
minus 15y. Well, I did a double negative y, I see, and then equals negative 63.
Equals negative 63. Okay. Now, you add your columns. That's how elimination works. Add your columns up. Okay. What's 10x and 9x?
19x.
So 19x. What's 15y and negative 15y?
0.
So that column is gone. And 25 minus 63.
Negative 38.
Negative 38. Okay. Now that we got rid of the y's, we just have one step left and then we know x. What's our last step?
Divide that by, or divide negative 38 by 19.
Divide by 19. And even though it looked like it could have been kind of a messy problem with those numbers, we get a nice answer for x. What do we get?
Negative 2.
Okay, so x is negative 2. What do we still need to find?
The value of y.
Still need to find y. And which equation do you think is easier to plug into? I would use one of the originals because the numbers are smaller.
The top one.
Yeah, I'd use the top one because they're all smaller numbers.
Single digits.
Yep. So I'm going to take x. I'm going to plug it back in right there. Okay, so we're going to have 2 times negative 2 plus 3y equals 5. Okay, what's 2 times negative 2?
Negative 1.
Negative 4. What will 3y equal? 9. Yep. And y equals 3. So you get x is -2 and y is 3. If we were to graph those, where would they cross each other?
-2 and 3.
-2, 3. Now, when you draw 2 lines, that's one thing that could happen. So these lines look something like that. They cross at -2, 3. What else could happen if you draw 2 lines? Besides crossing like that.
You will not touch.
They what?
You will not touch your mother.
And what kind of lines would those be?
Parallel.
Yeah, you could draw 2 lines and they're parallel. Or there's one other thing that could happen if you draw 2 lines.
Draw the same line.
Yeah, they could be the same line. Just the same line. Right on top of each other. So in this case, how many solutions do you get?
1.
You get 1. 1 point where they cross. How many solutions do you get in that case?
None.
No solution. And then how about this case?
Oh, we have solution.
Yeah, it's infinite amount of solutions. Yep. So there are 3 different cases that could come up, and I'm going to mention those right now.
Can I get another trick?
Yeah. So you've got the 1 solution where your lines cross because they have different slopes. You've got the no solution. That's when you got parallel lines. And you have an infinite amount of solutions. That's when you draw 2 lines and they end up being exactly the same line. That's the only thing that can happen in linear equations. 1 solution, no solution, or infinite solutions. Now, when you start looking at nonlinear, then all kinds of other things can happen. Right? Think of like a parabola and think of a line. Well, that could cross twice. So you could get 2 solutions. But here, you cannot get exactly 2. You get 1, none, or infinite. That's it. All right, so we'll take a look at a couple with elimination where we end up with the special cases. And then we'll get into a 3-variable. Let's try this one. All right, so first, what letter do we want to try to make disappear?
X.
Okay, so we're going to make x disappear. If we're going to make x disappear, I think we only need to multiply one equation by a number. What does that number have to be to make it cancel? It has to be a 6. So what would you multiply everything by?
3.
Yep. So we'll multiply everything by 3. Okay, so bottom equation is going to stay the same. And what does the top equation become?
6x minus 9y equals 15.
Equals 50. Yep. Don't forget to multiply that number on the other side. That sometimes people forget that one. You got to do them all. Okay. Add them up. Okay. What happens when you add up your first column?
Cancel out.
Cancels out. How about when you add your second column?
Cancel out.
That also canceled. So what's left on the left side? 0. And then add up your right-hand column. 25. Okay, when all your letters cancel, you're done. You just have to look at that and know what that means. 0 equals 25. Okay, so what do you think about that?
No solution.
That's a no solution. You ended up with a false statement. That's not the answer. The answer is no solution. So what kind of lines would these be if you put them in the calculator? They must be parallel lines. They have the same slope, but different y-intercepts. Okay. Any question on it? Okay, one more 2 variable, and then the rest of the class we're going to do 3.
Would this be a good one for substitution?
It would be okay for substitution because you don't have any number in front of the x. So yes, we could do substitution or we could do elimination. Since we did the last one with elimination, it's up to you. You guys want to do substitution or elimination?
Substitution.
Substitution? All right, so which equation would it be?
Top one would be the one we'd be substituting into something else.
And what would you solve it for?
X.
So solve for x. Okay, and what do you get when you solve it for x?
X equals negative 3y minus 2.
Yep. So you're going to add the 3y to the other side. You get 3y minus 2. And that's going to be plugged in for x. Where?
In the second equation.
In the second equation. Let's fill that in. Don't forget your parentheses when you substitute. So negative 2 times 3y minus 2 plus 6y equals 4. Okay. What's negative 2 times 3y? Good. And negative 2 times negative 2? 4. Okay. What's going to happen on the left-hand side? Right, we get a negative 6y. We got a positive 6y. That's gone. What am I left with?
4 equals 4.
I'm left with 4 equals 4. Kind of like the last problem. All the letters disappeared. You're left with a statement about numbers. So, what do you think the answer is for this one?
One solution.
One solution? Well, to have one solution, you've got to be left with an x and a y, kind of like this one.
Yep. Alright.
We're not left with any x's or any y's, so it is a special case. But which special case is it? Yeah, this is the infinite solution. Okay, that's infinite solution. Sometime what you might see, well, I guess for infinite solution, that's all you probably see. Or you could see all real numbers, I guess. But does anyone know the symbol you might see for no solution?
Isn't it?
I didn't mention the symbol. There is a symbol. Anybody ever see that symbol?
Oh.
So it's the only time in math that I know of where you use a Norwegian letter to represent your answer. We use Greek letters a lot.
Is that all real numbers?
That's no solution.
No solution.
So that means the symbol means no solution. So any questions on substitution with 2 variables or elimination with 2? All right, so if we can do 2, well, let's try 3. So the biggest thing with 3 variables is you're still doing the same thing. You're going to be trying to get rid of a variable, but you're going to have to do it multiple times. That's the difference. So I'll write the steps down, but I think it's easier to just try to go through it. So you're going to have 3 equations now. You are going to pick a variable to eliminate in 2 of them. So you're going to pick a variable to eliminate in 2 of the equations. Then you got to do it again. You have to then eliminate the same variable, but you have to pick 2 different equations because you're going to have 3. So pick a variable to eliminate in 2 of the equations. Then eliminate this variable again in 2 different equations. Once you do those first two steps, then you're going to have two equations, one from this step, one from this step, and they're each going to have only two letters in them. So then it'll turn into like the problem that we just did. Okay, so pick a variable to eliminate two of the equations, then eliminate this variable again in two different equations. So let's call this is step 1, this is step 2. Now, using the result from step 1 and step 2, solve for a variable. Okay, so by the time you get to step 3, you will be able to find one of your variables. Then do the same thing that we did before. Substitute it back in, and you can start getting your other variables. So the last step is really substitution. That's generally the process. Let's try it. I think one thing that can confuse people on this is you have more choices. You have more equations to pick from. You have more letters to pick from. My advice would be try to pick a variable that you think is easy to eliminate so you can avoid fractions. Okay, we generally don't want to deal with fractions. So here's our 3 equations. 2x plus 3y minus z equals -1. 3x minus 2y plus 2z equals 15. And x plus 4y minus 3z equals -8. Let's call this equation 1, 2, and 3. Any number that I write down in circle means it's an equation. Okay, so 2 circled means equation 2. 3 circled is equation 3. Now, there's one equation here that I would use as much as I could. Anybody know what equation I should use as much as possible, because it's going to be easy to use this equation to eliminate other variables because of the numbers in front of the letters? Yeah?
Is it the first one?
The first one? I don't think it's, I mean, you got a -1 here, so that's pretty good, but I see an equation that's even better. Which one?
3.
Yeah, I would use the third equation. What about the third equation makes it nice to use? Yeah. That you don't have a number in front of the x. That's going to make it easy to get rid of the x's in the other 2 equations. So let's start, doesn't matter, I would say start with equation 1 and equation 3. Let's use those 2. And what I would do in that equation, in 1 and 3, I would eliminate the x. Okay, first, I'm just going to copy them down. So 2x plus 3y minus z equals -1. If you notice I copied something wrong, just let me know. And then x plus 4y minus 3z equals -8. And the goal is to eliminate the x. Now, if the x didn't have a number, if it didn't have a nice number in front of it, then I probably would have tried to work with this -1 in front of the z. That's the next best thing. If you don't have a 1 or a -1, then this could start to get really messy with fractions. All right, so what could we do Well, you tell me which equation do I need to multiply first, and then we'll see what do we multiply it by. Will we multiply the top or the bottom to get rid of the x?
Multiply the bottom.
The bottom. Yep. What are we going to multiply the bottom one by?
-2.
Yep, -2. So the top, I'm just going to copy over. 2x, 3y, minus z. And now let's do out multiplying by -2. Okay, what's -2 times x?
-2x.
-2x. What's -2 times 4y?
8y.
-8y. And -2 times -3z.
6z.
6z. And -2 times -8. 16. Okay. Now, what do we do with all the columns? Add them all up. Okay. 2x plus -2x.
0.
There we go. Got rid of a letter. Now, if another letter disappears at the same time, that's great. Usually doesn't happen. What's 3y and -8y? -5y. What's -1z plus 6z?
5z.
5z. And -1 plus 16?
15.
15. Now, normally I would just stop there and I would call that new equation equation 4. But, and you could stop there, but what do you notice about that? Anybody notice anything about it?
All the 15 values is divisible by 5.
Yeah, everything is divisible by 5. If you can divide everything by the same number, make your numbers smaller, that's going to make it easier. So if we divide everything by 5, what do we get?
Y plus z.
And what's on the other side? 3. So I'm going to call that equation 4. So I've now created an equation that only has a y and a z in it. I need another one. I need another equation with only a y and a z. But I can't use 1 and 3 again. I got to pick 2 different ones. So what would be 2 equations we could pick to do this again?
2 and 4.
You got to pick from the original.
0.
Because we're trying to eliminate x. Which one?
2, 3.
Yep, I would do 2 and 3. So now, in 2 and 3, eliminate the x again. Okay, let's copy down 2 and 3. So 2 is 3x minus 2y plus 2z equals 15. And 3x plus 4y minus 3z equals, what did that equal? -8. Okay, so again, let's double check. 3, -2, 2, 15. 3, -2, 2, 15. 1, 4, -3, -8. Okay, looks good. All right. So which equation do I need to multiply here to get rid of x?
The bottom one by -3.
Yep. Let's do the bottom by -3. What happens to the top? It stays the same, yeah. So I know I copy it down a lot. You don't have to copy it as many times as I am. I'm just trying to show the work as clear as I can. So 3x minus 2y plus 2z equals 15. And what's going to be my bottom equation?
It would be -3x minus 12y plus 9z equals negative 24.
Positive.
Oh, positive 24.
Okay, add them up. All right, what happens with my x's?
Cancel.
Yep. They're gone. How about my y's? Negative 14y. My z's? 11z. And my constants? 39. Is everything there divisible by a number? So I'm just going to have to leave that. So now we'll call that equation 5. Equations 4 and 5 each have what letters in them?
Y and Z.
Y and Z. Now you can solve this just like we did the first problems. Write down 4 and 5 and pick what letter you want to get rid of. You can do substitution or you can do elimination. I would just stick with elimination, but do it either way. Let's write down 4. Negative y plus z equals 3. And 5. Negative 14y plus 11z equals 39. That's really your first major goal. Create 2 new equations that each have the same letters. 2 letters, only 2. Okay. What do we want to try to eliminate here, y or z?
Z.
Okay, so we're gonna try to get rid of z. So that means the z at the top needs to have what number in front of it? A negative 11. So what would you multiply by to make that happen?
Negative 11.
Negative 11. So we are going to eliminate z. You could have done y. Okay, lots of choices. And that's what messes people up. There's just so many different ways you can do it. Okay, what happens to the bottom equation?
Stays the same.
Stays the same. Okay, top equation. What's negative 11 times negative y?
11.
Okay. What's negative 11 times positive z?
Negative 11.
Negative 11.
11z. And negative 11 times 3?
Negative 34.
Okay. Add them up. 11y minus 14y. Y. Add your z's up. Gone. And then add up your numbers on the other side. 6. And y is negative 2. Now, that's really your second major goal. Find your first variable. Once you find your first variable, you're like 90% done now. Okay. What's one of the other variables we need to go back and find?
X.
X and
Z.
z. Well, I would use equation 4 and solve for z. That's a very, very simple equation. So let's use 4 to find z. So equation 4, negative y plus z equals 3. Okay. And what's y? Negative 2. So fill in a negative 2 right there. Negative 2 plus z equals 3. What's negative 2?
2.
Yeah. 2 plus z equals 3. So what's z? 1. Here's your second answer. And what's the last letter we have to find?
X.
X. So to find x, you can't go back to equations 4 or 5 because they don't have an x in them. You got to go back to one of your originals. Doesn't matter which one. Which one do you want to use to find x? I mean, I have a preference which one I would use. I would use 3 because x already has a number, doesn't have a number in front of it. So I would use 3 to solve for x. Somebody tell me, what was equation 3 again? X plus 4y
Minus 3c equals negative
8. Okay, x we don't know. How about y? What was y?
Negative 2.
Negative 2. Minus 3 times z. Z was 1. And when we simplify, that's our answer for x. What's 4 times negative 2?
Negative 8.
Negative 8. And then negative 3 times 1?
Negative 3.
Negative 3. Okay. Negative 8 minus 3?
Negative 11.
Negative 11. And then add 11. What's negative 8 plus 11?
3.
3. There you go. There's your 3 answers. So 3, negative 2, positive 1. Okay, so in terms of like the method, there is no new method. It's just elimination, but you have to do it a lot more than a 2 system. And then that's why if we were to do a 4 variable system, then elimination, if you do it this way, it works, but it's even longer. So when you start getting above 3, you need a more efficient way than this. Okay, so any questions on steps that we did? So it was really 5 major steps. Create 2 new equations. That was steps 1 and 2. Step 3 was to get our first variable. Step 4 was our second variable. And then step 5 was the last one. Once you get the first one, you're 90% done. You did all the hard stuff. Any question on it? Yeah.
How many questions of the 3 variables are going to be on homework?
Probably 1 or 2. Yeah, maybe 1 or 2. Same thing on a test, probably just 1 or 2. Because if you go through it, pretty quick, it still takes you probably about at least, say, 8 or 9 minutes to go through that one problem. Now, I don't know if you noticed when I was checking if I wrote it right, I looked up above when I copied it and I said, all right, 3, negative 2, 2, 15. 3, negative 2, 2, 15. All I did was read off the numbers that were in front of the letters because I know it's an X, a Y, and a Z. Well, if you write something without any letters, that's what a matrix is. Right? So this will be the last thing I write down and show you. I'm not going to do anything with a matrix today. That's going to be what we learn later in the week. So a matrix is just a more efficient way of writing everything down. And it's also a more organized way. When we did that last problem, we had all kinds of choices. Let me go back to it for a second. First thing I said was, I want you to pick 2 equations. Right? So you get choices right there. 1 and 2, 2 and 3, 1 and 3. Then, once you pick 2 equations, I want you to pick a letter to eliminate. Well, you have 3 choices, the X, the Y, or the Z. So, lots of different ways that you can start the problem. When we learn how to do this as a matrix, everybody will solve it in exactly the same order every time. There are no choices about what you do first or what you do second. So for some people, that makes it just easier. It's less to think about. And writing it down, just that part in itself, is also a lot shorter. If you write this as a matrix, this is what it looks like. 1, 2, 3, 1, 4, and 10. Those brackets are used to tell you that those numbers are part of a matrix. And a lot of times when we start writing matrices quite a bit, we just leave the brackets on the side off. But if you want to formally write it, this is how you do it. And the numbers represent what's in front of the letters. 1, 2, that's that. 3, 1, that's that one. And then this line is put there to show you the 4 and the 10 were on the other side originally. That's what the vertical line is for. And that's it. That's how you write a matrix. So tomorrow what we'll do is we'll review. Okay, we'll go over the homework, and then tomorrow just a review day on 10.1. So make sure you have your Chromebook, because you'll need that for the review guide. And Wednesday, I'll talk more about these, and we'll review those on Thursday. Okay, so let me just double check that. Just in case there was any fun questions I missed, and I can give you extra.
Wait.
All right, so 1, 3, 5, 7, 9, and 11. Those are all 2 variable. 13 is 2 variable. 15 is a 3 variable. And 17 and 19 are 2 variable word problems. One of them is similar to the rectangle one that we did at the beginning of class. So there's 1 3 variable problem.